Hello, you have a copy of a jamboard entitled Scrambled Proofs. Directions are here. We want you to unscramble the statements and reasons of each proof so that your proof is presented in a logical, chronological order. So at first glance, this proof looks complete, but it's not, because these statements are not in the right order. These reasons don't justify the statements. So what we want you to do is check out the two triangles that are there, look at the given information and see what you're trying to prove, reorder your statements, and be sure to reorder the reasons so that an appropriate reason justifies each of your statements. Do that for the problems on frames 2 and 3. So pause the video now, complete those two frames, and then come back and we'll compare your answers with ours. So here is my answer key, and I'm going to show you how I proceeded. Let's see if you did something similar. First thing I did was when I noticed the given information that BU is congruent to UG, I put the tick mark on each one of those sides. UM bisects MG, so I knew these two pieces are congruent. I did two tick marks. Next, I decided to put my given information first. So I dragged this up to the very top, justified by given. Next, I used the definition of segment bisector to state that BM is congruent to MG. Now I'm using reflexive property to show that UM is congruent to itself. Now I have enough information to show that the two triangles in this picture are going to be congruent. So triangle MUB is congruent to triangle MUG by side, 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 triangle congruence postulate. Remembering what we know about rigid transformations, triangle MUB, if I reflected it over this line right here, would land in triangle MUG. So we want to prove that angle B is congruent to angle G. We take our congruence statement. We notice that B is the last letter and G is the last letter. Therefore, they are corresponding parts. So by corresponding parts of congruent triangles are congruent, or CPCTC, we know that angle B is congruent to angle G. Now, the problem on frame number 3. Once again, I marked up my diagram. If C is the midpoint of BD, then BC is congruent to CD. If AB and BD are perpendicular, then they form a right angle. Same thing over here, a right angle is formed if ED is perpendicular to BD. I want to prove angle A and angle E are congruent. I start with the given information that C is a midpoint of BD, that's given. I then go on to say, by the definition of midpoint, that BC is congruent to CD. So what I do when I complete these proofs is I start with the given information, and then any fallout from the given information comes next. So there's another piece of given information that these sides are perpendicular. That's given. And the fallout then is that the angles are right angles because perpendicular lines form right angles. The next thing that I want to point out is that angle B and angle D must be congruent by the right angle theorem, that all right angles are congruent. Next, we can talk about these vertical angles. So I happened to notice when I was marking up my diagram that these are vertical angles. Now let's mention it in our proof that angle BCA is congruent to angle DCE because vertical angles are congruent. Now it's time for us to state that these two triangles are congruent and be specific as to what reason. So I've given you the reason of ASA, angle side angle, that angle ABC is congruent to angle EDC. because we have an angle, the included side, and an angle, congruent to an angle, the included side, and the angle. And the last thing is we're trying to prove angle A is congruent to angle E. We can do that by C, P, C, T, C. Now for an exit ticket. Take this bar and slide it to show your confidence level with triangle congruence proofs. How do you feel about what we've been learning? And then explain your rating if you choose to.